Hello, Petya. Thank you and welcome you to our YouTube channel of Grupo Faña. I am here with Vladimir, General Manager of Grupo Faña, and my name is Melvin Cava. How are you today?
I'm great. I'm really great, Melvin and Vladimir, and I'm very glad to be with you and to be with your customers today.
We are delightful to have you in your channel.
Thank you.
So, Petya, can you please tell us a little bit about yourself? Who are you? A little bit about your background?
Yeah, I'm very happy to share this with you. My name is Petya Tatarska. I'm the CEO of INNOVA BM. My education and background are mostly in international business, and I have further specialized in cosmetics and personal care. I have the great honor to be Chief Executive Officer of INNOVA BM, which develops and produces plant stem cells and plant in vitro culture in general as raw material for the cosmetics industry, food supplements, and the pharma industry. INNOVA BM is a comparatively new company to the cosmetic world. Our first project was launched on the market immediately before the COVID-19 pandemics. But despite of the hurdles at the very start of our existence, we've made considerable roads on the market of cosmetic ingredients. We have a global presence with direct sales and distributors on 5 continents. And we have been able to achieve this considerable growth because of the exceptional efficacy of our ingredients.
Oh, interesting. So how did INNOVA started or originated with the idea of producing such a complex active, such as plant stem cells?
Well, plant stem cells and plant in vitro biotech in general is a promising solution to a number of the greatest global challenges of our time, like the rise of population and the need to feed it, the degradation of the soils, the increasing use of pesticides and herbicides, the problem with the deforestation for the purposes of clearing more and more land as agricultural land. All these global challenges need to be addressed in some way, and plant in vitro biotech, plant stem cells being kind of part of this global umbrella term, plant in vitro technologies, they provide a good solution for all these problems. So we were excited to launch our business in this area, which promises alleviation of some of the challenges that the humanity faces.
Oh, I see. Given your experience in the area, why do you believe that the variety of stem cells are so scarce, so difficult to find? And how do you identify which plants are the right ones, the correct ones? How do you get to them?
Yeah. Okay. So let me explain you in brief how plant stem cells are created, to show you.
Okay, you can see it now.
What this technology entails. So we start with the plant itself. And here I would like to elaborate on your question, how do we choose which plants to work with?
Okay.
This is a very interesting question, very important one, because the process of creating plant stem cell, developing plant stem cells, is a long one, an expensive one, and it is really worth it to work with the best plants that have the qualities that we desire, because we are speaking of cosmetic ingredients and we're speaking of cosmetic qualities. We in INNOVA BM prefer to work with plants that have proven cosmetic properties. For example, calendula in our lands, in Bulgaria, in Europe, has been used for wound healing for centuries. So we already have a plant that has strong cosmetic properties. And with the help of this in vitro technology, we enhance the natural qualities of the plant. So we enrich something that is already rich in secondary metabolites with the cosmetic benefits. We start with the plant, let's say calendula,
Okay.
and we cut parts of the plant and sterilize them, and then induce them to start producing de-differentiated cells, which are cells they can then turn to any other tissue. And these cells are taken away from the plant, transferred into semi-liquid media, and induced to start replicating, to start reproducing as individual cells. At this point, we have the so-called callus. This process can take a long time. This process can take between weeks and months. And then we have an even longer process of transferring the callus into a liquid media and selecting the cell lines that are the richest in terms of secondary metabolites, the quickest in reproduction. Also, during this stage, we optimize the phytochemical composition. That is, we make the cells produce more of the valuable substances to overproduce the secondary metabolites. And in this way, when we finally have cells, individual cells and cell conglomerates growing as a biomass, not as a whole plant,
Okay.
then at this stage, we have a much better cosmetic properties compared to the natural plant.
Interesting. We are also, just so you know, very interested lately in the so-called resurrection plants. Can you tell us a little bit what is it obtained from these extracts and how does our skin benefit from it?
Yes. Well, resurrection plants are a very interesting group of plants. They are comparatively rare. I think that there are about 200 resurrection plants in the overall great wealth of flora on this planet. The most characteristic things about them is that they're equipped to withstand long periods of drought, long periods of harsh conditions. And when the conditions improve, the plants come back to life fully. In order to do this, in order to be able to stay alive during long periods of harsh conditions, they develop mechanisms, they develop ways to protect themselves. And these molecules that are responsible for the resurrection mechanism are very valuable raw materials for the cosmetic industry and also as food supplements. I will give you one specific example.
Please.
Haberlia rhodopensis is a resurrection plant with one of the strongest resurrection mechanisms on Earth. It can go without water for 3 years.
3 years.
And of course, for 3 years, it will become completely dry. And you take the completely dry plant, put it back in water, and it comes fully to life. The reason for these amazing properties is the rare molecule miconozide, which is biosynthesized only by Haberlia and one other resurrection plant called Ramonda serbica, and a couple of other plants. So miconozide is responsible for this resurrection mechanism, and miconozide, when used in cosmetics, brings great benefits to cosmetic products. Miconozide is proven to stimulate the production of collagen and elastin. It also has a very strong, very high antioxidative properties, which on the skin translate in anti-inflammatory action, in anti-pigmentation, in brightening of the skin. So resurrection plants are a very, very valuable source for the cosmetic industry.